Hello everyone, welcome. Thank you for joining today. I hope you are all safe and well. My name is Riley and I'll be your host for this session. Um, just before we get started, I'd like to just go over a couple of things. And that is just to turn off your notifications or sounds in the session. And that is basically just to stop any pop-ups or sounds during the session which may impact on your viewing. So you can do that now by just going to your settings in the, if you're on desktop, it should be in your bottom right hand corner in My Settings, or if you're on mobile, you might need to open the session menu and go to Settings and untick all the boxes under Notification Settings, and that'll stop any pop-ups or sounds during the session. So today's technical topic webinar is SCADA display design based on abnormal situation management guidelines. So that is our technical topic for today, and it is being presented by two of our lecturers here at EIT in the industrial automation field. So Mr. Santosh Anantha Krishnan and Dr. Aklaka Raman. So Santosh is a lecturer with us, and he's also working as a SCADA and RTS engineer. And AK is a course coordinator and lecturer for the industrial automation engineering field at EIT. Now, for our webinars, for our technical webinars, you will receive a copy of the slides and a link to the video recording after the webinar, usually within one business day. We also offer a free digital certificate of attendance to those who would like one. If you would like to receive a certificate of attendance, please wait till the end of the session. And there will be a link provided or a QR code to a short form or survey that you need to fill out in order to receive one. And once you've completed that short survey, I'll send you your certificate within the next business day. Now, just a quick overview of EIT. We are an engineering specialist education provider. We have a range of courses such as short courses that we call professional certificate of competency courses, as well as diplomas, advanced diplomas, and in the higher education space we have undergraduate and graduate certificates, bachelor's and master's degrees, and a doctor of engineering. Now we only offer engineering courses. We're dedicated to teaching engineering. So that's part of what makes us unique at EIT. We have industry-oriented programs, so our programs are regularly updated to stay relevant with the industry. We have accredited education in Australia, so all of our vocational and higher ed degrees are registered and accredited by the Australian government, but in addition to that, we do have courses that are recognised by the International Engineering Accords, and you can check out our accreditation on our website if you're interested in that. We have industry experienced lecturers, so not only are they involved in academia, but we have a range of lecturers around the world that are currently working and can add valuable knowledge to their teaching through their experiences. And we have a unique delivery model which includes live and interactive webinars, our international pool of expert lecturers. We have dedicated learning support for our students, and also state-of-the-art technologies such as workshops, remote labs, and simulation software. Now the agenda for today, so I've just done the introduction, then we're going to talk about what is abnormal situation management, or ASM, ASM guidelines in SCADA display design, examples of ASM guidelines and displays, And then finally, we'll talk about studying industrial automation at EIT and some of our programs that we offer in this field. And then we will hold a Q&A session at the end for those who may have any questions for any of us. Now I'll hand over to Santosh now, who will just briefly introduce himself. And yeah, thank you for being here today, Santosh. Thank you.
Thank you, Riley. Happy New Year to everyone present. Morning, good afternoon, good evening, wherever, whichever part of the world you are in. I'm Santosh Ananthakrishnan. I've been an EIT lecturer taking SCADA and distributed control system unit. I'm also a senior E&I engineer working for a company which does high pressure gas pipeline. And I've also worked as a SCADA and RTS engineer in my career. So I'm a chartered professional engineer with over 15 years of experience in the field of electrical instrumentation and most importantly, SCADA and control systems engineering. I worked in all various phases of the project, like concept, detailed design, commissioning, through to close out, and I have a strong passion to deliver all the projects in a safely, and most importantly, on quality, cost, and schedule. In my experience, I've configured many SCADA systems for hazard industries like oil and gas and chemical plants. I've developed quite a lot of operator displays incorporating abnormal situation management guidelines. As a result, I have seen that the operability of these facilities have been enhanced. So when I'm presenting, let me see how much I can get my experience that I have gained over the years and see how I'll present those experience to you through my slides. So that's a quick introduction about me. I'll now pass on to AK.
Thank you so much, Santosh. Hello, everyone. So my name is Dr. Akhlaqur Rahman, and as everyone calls me AK, easy to pronounce. So I'm basically the EIT course coordinator for industrial automation and also full-time lecturer at EIT for almost 3 years. I did my PhD from Swinburne University, and I have almost 10 years of experience now in teaching electrical engineering, electronics engineering, as well as industrial automation courses in Australia, as well as in overseas country like Bangladesh, where I'm originally from. I am currently a member of Engineers Australia and also a senior member of IEEE for the last couple of years now. So I think yeah, almost a couple of years now. My PhD topic was on task offloading algorithms on cloud robotics for Industry 4.0. So as you can see, cloud robotics, Industry 4.0, quite a multidisciplinary area, but also relevant to the topic at hand today, and also industrial automation that we'll talk about later on as well. Yes, and that's also my research area at the moment as well, industrial IoT, cloud robotics, virtual manufacturing system, and so on. Besides that, I'm also currently the secretary for IEEE Young Professionals Committee, and actually the newly appointed secretary for IEEE Victoria as well. So looking forward to the presentation today, quite a relevant and interesting topic. So I'll hand it back to Santosh. All the best.
Thank you, AK. All right. So what are we seeing here? It's just it's a picture of a process plant, right? I think it's a gas processing and a compressor plant. That's what that plant should be, from my experience. So process plants produce like many products, like maybe you know that, like in today's society, which are like those products are used in like quite a lot in today's society, like oil and gas, or like fertilizers and plastics. So in a process plant, there are like many process parameters, right? Like that may lead to an abnormal situation if they are not actually controlled properly and in a time effective manner. So some example of these process parameters like pressure, like high pressure or temperature, flow, toxic substances. They could be like moving machinery, electricity, and all that. Right. So the key drawback of such plant is their like operation involves risks, right? Because the process parameters, if they actually go into an abnormal zone, then it might actually cause like a lot of risks. So while these risks we can never actually bring it to zero, the goal of the design of these process plants is to keep them as low as practicably possible. So with that, let me probably give you an description of what an abnormal situation is, right? So abnormal situations are undesired plant disturbances or incidents with which the control system is not able to cope, requiring a human to intervene to supplement the action of the control system. It could be a simple upset where an operator can like come in and he can fix that upset, or it could gradually or drastically escalate to a critical incident where we probably require like other systems like safety systems to get engaged, right, and then bring the process to within the boundaries of its operation. Or it could even go even further, that you kind of have to have an evacuation or a rescue operation, right? So usually what happens is like human error is blamed, and a lot of companies spend a lot of like engineering effort and dollars to increase the training, so to provide solution to help the operators in ensuring that they take appropriate decisions, and so that they can maintain the process within its band of operation. So that is the job of the control room operator, right? Like with the assistance of the operation team to identify whenever the process like deviates beyond its boundaries, and to determine what caused the situation, what corrective action that can be implemented, so that the process comes back within its boundary of operation, like in a timely and in an effective manner. Okay. So what we are seeing here, like on the left of the side, it's an example. The picture is the left picture is an example of a multiple independent protection layer that can be used in a plant. As you can see that the process is at the center, and there are various protection layers, and each of the protection layer kind of reduces the overall risk that the inherently that the process actually has. The inner layer help prevent the hazardous event from ever occurring. So when you talk about the inner layer, it is the basic process control system, then the alarms and operator intervention. So that layer is where we will be concentrating more on our discussion today, because that's where SCADA displays actually come into the picture. And then there are safety instrumented system, and then you kind of like have your physical protection. Example is some relief device like a PSVs, followed by like a physical protection dikes, or like a boundary valves or bunds. Then plant emergency response and community emergency response. So the inner layer help prevent the hazardous event from occurring, and they're called as the protection layer. And the outer layers are used to lessen the consequence of the hazard, right? Even once like once the hazard has actually occurred, right? And they are referred to as the mitigation layer. Like if you think about the plant emergency and the community emergency response, they target at lessening the consequence of the hazard event. So for example, for a plant emergency, let's assume that if there is a doctor in the plant, so who can actually provide an immediate medical attention, and it can save life, right? So the organizations which are operating these high hazard facilities will need to think about having medical facilities within the plant. Or if you think about community emergency response, it could be like a fire service station which is very close to the plant, and the event of a fire, then they can come in and extinguish the fire and save any damages to the community. So what this picture here depicts is the evolution of an abnormal situation, from some initial cause producing an operations upset to a catastrophic disaster, like involving serious destruction or harm to the plant or the surrounding community, right? So like you can see that the deviation from target operating range on the y-axis, and the modes on the x-axis, where kind of like if it is deviating and it is just a normal deviation till the green zone, it is still okay. Probably the control systems might come into the picture, and it will try to get it within its operating region. But as it starts to go into the yellow region, that's where the process plants will start to see like increased cost. There might be like a reduction in production, or it might lead to off-spec product. And finally, within that yellow region, we might probably see like there is no production and equipment damage, right? So that is where the other layers of protection starts to come in, right? And then when it goes into that emergency mode, that's where you kind of gone into that mitigation layer, where there could be like loss of life or fire or explosion or like other environmental releases. So in an abnormal event sequence, right, the modes of the plant progress from normal to emergency, and like eventually like it could escalate to emergency, right? If there are any failures in the critical systems or operations or technical support activities, that is very critical to maintain the process within its boundaries of operation or within its normal mode of operation. So the critical systems are like the safety shutdown system, the physical and the mechanical containment. Then there are like emergency response layers, which actually provide safeguard to the plant in a catastrophic event. So the role of the plant operator is very, very critical in this. Like he has to identify the event, and then he has to act on the event to prevent this process upset, and eventually ensure that it doesn't escalate to either a plant shutdown or to an abnormal or an emergency mode, when the control system is actually given up hope and it cannot do that control. With that, what we will be discussing in this webinar are the guidelines that can be used to build SCADA displays when an abnormal situation occurs, right? So it can help the operator to make appropriate decisions to control the process in a timely manner, so that the production can continue safely, and none of the modes other than like an abnormal or an emergency mode, if the process happen to go into the zone, it can be actually successfully brought back into the normal zone mode. Okay, so what you are seeing here, these are the 16 categories of abnormal situation management, like guideline categories. Each of these categories, they have their independent guidelines, like multiple guidelines under like each category. And when you use these guidelines, it will help you the designer to achieve effective practice to build a SCADA display. So if I just quickly go through these categories, starting from like the display types, display content and task appropriate information, display style and layout, navigation, use of color, use of symbol and process connection, use of text and numbers, right? Interaction with displays or alarm configuration schemes, audible annunciation of alarms, visual annunciation of alarms, training program and online user assistance, design methodology that can be used to build SCADA systems or displays, and the management of SIM. So the critical point to be taken here is the implementation of the individual guideline in itself will not guarantee an improved effective operations practice, but together all of these guidelines will form an integrated program that will lead to quite a lot of improvement. So that is what is seen when these guidelines were actually implemented on process facilities. So what I'll do today is, I might probably not have the time to go through each of the points under each of those categories. So I'll probably touch on some of the critical guideline under each of these categories. So starting from the display types. So the first guideline is use a process overview display, right? That kind of gives an operator a bigger picture, and also helps him be aware of any problems within their plant. The next one is use standard display hierarchy to represent multi-level views necessary for monitoring and control, right? So with a consistent display hierarchy, operator will know where to find the information they need. Then use multi-level views based on process equipment hierarchy for monitoring and control, right? So with that, he will be able to know where a particular process equipment is located within the set of displays that he's got, and which will help him in troubleshooting. And also make it easier for him to navigate between the various displays to determine the root cause of the problem, like within his plant. And the last one is like use dedicated display to support response to critical upset conditions. So dedicated displays for critical upset conditions, it will help to engage the operators in an appropriate mode of interaction, right? And it kind of like removes any noise from the operator, so he can concentrate on the problem at hand. And it will provide key information for handling these critical upsets so that the operator can act on those key information. Right. So what you're seeing here is an example of an process overview display. I think that's an nitric acid plant. It pretty much shows you the raw material like coming in from the left, and then like pretty much like nitric acid being manufactured and sent out. Right. So this kind of a display allows the operator to see the bigger picture and also maintain like awareness of potential problems within their control. So that's an the previous display. They usually call it as a level 1 display. And the second guideline that I'll discuss today under display types is the use dedicated display to support routine activities. So what you're seeing here is like it's called as a level 3 display. Again, it's in a nitric acid plant. It's an absorber. So if the operator wants to like look at what is happening within the absorber, how are the process parameters within the absorber are currently doing, then he can come into this display and he will be able to control the key process parameters like whether it is level or flow or pressure, right? So kind of this dedicated display, especially for like the routine activity, where the routine activity is for him to come and make sure that the absorber is functioning appropriately, right? So this will provide him, it will engage the operator so that he can interact with the process. This will also reduce chances of like mistakes or any misinterpretation. So the next one that we will see is the ASM guideline on display content, right? So the guideline is use context sensitive techniques to access information that is conditionally relevant. So context sensitive techniques allow the displays to change with the operator needs. In this way, the display can contain more information while showing only the needed information to the operator. Like it, not all times all information is required by the operator, right? Like if you look at the example on the left, he kind of like right click on a particular vessel, and he can click on like show me the tag name of this object, or show me the unit of this particular transmitter, right? Where he doesn't need to know all the time, and when he needs to know, he can right click and bring that kind of information. It can be also used to like acknowledge alarms, right? Or call up a trend. And what you can see on the second picture, like it gives you the operator and option to kind of have a lot of menus, and he can click on that appropriate menu to look at the information that he's after. So what this kind of helps, right, is that we don't cloud the display with so much information that the operator is like confused. So you give the option to the operator for him to navigate or call up information when it is required for him. Okay. So the next guideline is actually with the display style, and then the guideline itself is ensure that the overall style incorporates an effective use of half intensity displays, right? So what is important is it's important to draw the operator's attention to the most informative part of the display, right? Which is either the process value or the alarm, and reduce their attention to objects that do not change. Like for example, like equipment layout or like flow lines. Like if I'm working as an operator in a process plant, and I have a display that looks like the one that on the left, I might probably resign my job, right? If I'm going to be, it's a pain to look at the display day in and day out to actually control the process plant. Whereas if you look on the right, that is much more soothing to the eyes, and there's a lot of good information that the operator can see. So at the moment, I know that this main fractionator overhead process is running very well. There is no alarms in it, and I don't really have to like do act upon it. So right, so that kind of like reduces all the visual noise to the operator. So high contrast colors makes it very difficult to see process changes, whereas the low contrast colors makes process data more visible. When people talk about ASM, usually they say like a gray background, or like you use gray a lot. It doesn't need to be like always gray. It depends on the display design, and that should be actually using the abnormal situation management guideline, and how your organization and the operators in your organization like use that guideline for their benefit. So the next one we will be seeing is the ASM guideline for display style. So the guideline itself is depict equipment without excessive detail to facilitate quick identification. So I've got like a couple of pictures on there. So the first one is you got a blower, right? Like it just got an impeller. So that's kind of like an excessive detail to an operator. He really doesn't need to know whether the impeller is rotating or not. So what he needs to know is how it looks on the right side of the picture, with which it says like if it's a with some color notation, like a dark gray saying that it is running and a light gray saying that it is not running. Right. So what this does is you have to avoid representation of equipment object with more detail than necessary. Like I was a graduate engineer many years ago, and I used to take quite a lot of happiness, and I feel proud whenever I animate displays. Like I used to like seeing these impellers actually rotate. Right, but then over the years, it was found that it is not going to add any value to the operator. It is only going to be more of a distraction to the operator, and reducing the amount of like the unwanted information on a display actually aid in better response for the operator. So and like having said that, like equipment details need to be still included where it is required. Like for example, like instrumentation lines, or like if you want to like include a pressure differential across some tray, right? Like you need to still show that level of detail, because that will be used for a maintenance engineer or a maintenance operator who might look at the display, or like so it is very important to like remove uncertainty, like or like in the process flow connection. So sometimes you might have to show the process flow connection, so that people are the operators are clear where the process flow comes, and that level of information still needs to be included in the displays. Okay, so the next guideline is about the design layout and develop consistent display layouts that are appropriate to process behaviors with consistent direction of flow. Right, so the consistent direction of flow is a very critical one, right? Like if you have a display that has got flows coming from left, right, top, bottom, or top left corner, top right corner, it will confuse the operators to a great extent, and especially when he's looking at the display during a abnormal situation, trying to bring it within control, it's not going to help him at all. So you need to have like consistency when building these displays. Like usually the process should go from left to right. Yeah. So the layout of these operating displays affects the ability of the operator to quickly identify any key process components and relationships, right? So that is very important. So operators can locate information more quickly when the displays are done in a consistent way. Since they will know where to look at, and this consistency, it will decrease the time and the error in locating critical information, and this time they can actually use to act upon that process upset, because before it kind of like escalates, right? So and also, like when you develop displays, you should have a consistent location for some of the common objects, like display titles or navigation bar or the equipment labels. So because some consideration has to be given for information that needs to be viewed simultaneously to accomplish like critical monitoring and control tasks, right? So if you look at this display, I can say mostly the flow is from left to right. and they have used consistent symbols for pumps, for regulators, for on-off valves. The alphanumeric, which are representing the various process parameters, that is all consistently shown. So these are some of the important guideline that needs to be implemented in a display design. Okay, so the next one is the this is again on display layout. Ensure that layouts capitalize on maximizing operator retention of information in term memory, right? So different layout can influence operators' capability for retaining the fixed information, right? So information that is related and grouped together in a way that shows the association or relationship will be easier to remember, right? To a display that is not having a proper grouping scheme. So if you look at it, the picture on the left, the information is kind of like scattered. And for an operator, it might be difficult to locate that information. Whereas the picture on the right, where the information is kind of like together, so the operator will be able to quickly get his eyes to that information and can make meaningful decision. So process where values can be like put inside process equipment. They can be put on the side of the process equipment, depends on like where the process value is, but it needs to have that consistency. Okay, so the next one that we'll be seeing is the ASM guideline for navigation, right? Ensure that navigation scheme is fairly simple and flat, right? It should be like that more for process plants which are like having multiple plants. Like I worked on a plant where there are 3 or 4 process plants in there, right? So if you look at the top example, for him to go from display which is in plant area 1 to a display in plant area like B, he has to perform like 6 clicks before he can get there. So operator should be able to move very quickly between displays in a error-free manner, right? So a broad and a shallow display hierarchy will better support this requirement, right? So yeah, and it will also not frustrate the operator in finding information if you have such an like an hierarchy. So the general rule is the operator should be able to get to any display within like around 3 to 4 clicks. So that is what we are actually seeing at the picture in the bottom of that slide, where to go from the display A to which is in a one plant to a display B in another plant, he clicks to the level 1 display, and then he drills deeper to the level 2 display, and then to the level 3 display, and to the level floor display. So kind of like in 4 clicks, he will be able to get there. And if it is implemented in a consistent way, then he will not have any confusion on getting to the information, and he will be able to do it in a timely manner. And also consideration should be given for like menus and buttons for key displays for the operator to navigate. Like if he wants to quickly look at a status of a trip, then he probably has got a button located like on a menu bar, and he can click on it and quickly get there. So he shouldn't be clicking multiple times to get to such key information. Okay, so the next one is use of minimum color codes consistently across the displays. So consistent and distinguishable color codes, like it allows operators to learn the codes and their meanings, right? So where if you look at the display on the left, I know that there is an emergency alarm on one of the transmitters. There is a high priority alarm on one of the transmitters. We can see that the pump is actually in manual mode. So also like some in general, the color coding to indicate materials in a process line is actually not recommended. But having said that, if the organization and the operators feel that it is going to aid them, then yeah, color coding could be used in the process line. So if lines are colored based on material they contain, then implement the color so they can be toggled on and off. So that's a takeaway. Like although it is not recommended, right? But if the operators feel that having the color, for example, if they've got a water line and they want to see a blue color for a water line, give them that feature. But they should be able to turn off the feature. So usually it will be normal colors, and if they want to see, they can come and click on a button, and that will provide them that information. So the next one is again on navigation, so use brightness coding sparingly for salient like use brightness less. Like if I look on what I've got on the left of the screen, it is too bright to me. It is not providing me the information that an operator needs to make a decision. But when I look on the right side, I know that the PV is probably is in manual mode. I know there is an emergency alarm on one of the pumps, which means that I might probably have to contact the maintenance team to make sure that that alarm goes away. And if we want, we can get that pump to actually run. Um, Okay, so the next guideline is use of symbol and process connection. So use symbol and line coding that is easily understood with appropriate salience. So with consistent coding and appropriate salience, what happens is the operator will be able to focus on the most important information first. This will also ensure like fewer errors in identification and recognizing the equipment and the flow lines and the process information that the display is trying to communicate to the operator. So if you see that on the right, there we got like thicker lines, which are the main process lines within that display. Whereas on the left, first of all, it is too colorful, and also all the line thicknesses are the same. So for a seasoned operator or a new operator, it will be very difficult to identify which process this display is actually showing him, like which is the main process in the display. So the next one we are seeing is the use of symbols and process connection. Again, the same. So another guideline is have a simple and consistent set of symbols, right? And that can eliminate confusion and operator error. Like having that consistency is very key in abnormal situation management, like compliant displays, right? So the example that has been used like is the line width and the gradation of grade to the code process lines. So it does not show like any outline to the equipment. Like if you see that the equipment, most of the vessels, they are kind of like nicely are embedded in the display. It doesn't have a very thick line, so it kind of like draws the attention of the operator. So it is very easy on the eye of the operator, and there are no like visual noise on this display to the operator. So symbols used in the displays are consistent, and they have a meaning, and it is important that it carries the same meaning when it is referenced in like other documentation, like for example training manuals or operating procedures or like maintenance procedures. So you sometimes what happens when you do the training manuals is like not sometimes, most of the time is you take a copy of this display and then you put it in the training manual so that you can reference between the training manual and the display. So having that consistency between the documentation and the display helps a lot in operator training. Yep. Okay, so the next one is use of text and numbers that are eligible for users' typical position. So black text on white background and sans serif font makes process values very readable. And also consideration has to be given for like older operators. So if you have a very small font, it might be difficult for the older operators. So a good size font that will help like a range of the operator age will definitely, that's how the display needs to be built. Okay, so this one is use of text and numbers. So as you can see that use mixed case lettering for text messages, right? So if you have got like isolated word, upper case text are recognizable and easy to read, while if you have like a sentence, then like a combination of upper and lower case print is more easy to read. So the main the example is the main fractionator overhead on the top picture. It's easier to read when it is like a sentence case as opposed to a flare, which is on a single word on the in uppercase is easier to read. Okay, the other guideline is interaction with displays. Ensure that the size and distance between the selectable display objects is appropriate to the precision enabled by the pointing device, right? So the display could be called up on a mobile phone, or it could be called up on a PC. So you have to just make sure that like whatever is the selecting object, whether it is a pen or it is a mouse, the objects are not are far away so that it doesn't annoy the operator or he selects the inappropriate object to get the incorrect object to get the information. So that level of like the display segregation, like the minimum separation distance between the selectable objects. For example, for a touch screen, they say it is a 0.25 inch, compared to for a mouse, it is like a zero 0.1 inch. And then minimum area of the selectable object, what is recommended is for a touch screen, it is 0.75 square inches to as compared to an using a mouse is like 0.08 square inches. So the next guideline is ensure that an auditory indication is given when an invalid entry is detected when error avoidance techniques are applied. So that means that if the operator is going to perform an entry and he makes a mistake in that entry, for example, if there is a range for a set point of 0 to 50%, and by mistake he enters 55%, and he moves his eyes away from it, the entry, he might think that the control systems has taken the set point, whereas it is not. So in those conditions, if you can give an audible indication, that will draw the attention of the operator and he can actually fix his mistake. Okay, so some guidelines on alarm configuration schemes. So ensure that the display are available to view. There are displays available to view disabled and inhibited alarms. So sometimes alarms have to be like disabled and inhibited, but operator need to be aware of the specific abnormal plant conditions, because they won't be actually enunciated because they are disabled and inhibited. So there should be a display where he can routinely go and have a look what are the alarms that are disabled. The next thing is provide information on alarm configuration settings that deviate from the designed values, right? So this means that if an original setting of an alarm is, let's say, 40% high level, and if that setting happens to be changed to 30% because of some process condition, and it is an intermediate change, so providing that original setting information to the operator will give him that information about the process, and he can keep an watch when any of those alarm settings are actually hit on the process. The third thing is provide access to alarm rationalization information, right? Like quick online access to that kind of information will help the operator, especially when it comes to like infrequent or like uncommon alarms. So if it's an alarm that he's never seen during his time on the desk, right? So that kind of information will give him the background, why this alarm has been actually configured, what is the next steps that he has to take in order to like keep the process within the operating boundaries, what he has to do to actually make sure to he can like fix the alarm so that the alarm goes away. Okay, the next guideline is audible annunciation of alarm. So ensure alarms have appropriate intensity to be audible. Like what it is you can configure audible alarms, but don't keep it like too audible such that it is actually a nuisance to the operator. It shouldn't startle him whenever the alarm comes, right? So keep that the intensity of the audible alarm appropriate to the operator, that he should be able to hear and act on it, but it should be it should not be a nuisance to him. Have priority based audible bypass for upset conditions. That means that in a process upset, you might get lot of alarms, and many alarms could have like audible alarm configured to it. So if you actually configure a bypass where under a process upset conditions, it kind of like removes that audible feature of those alarms, so then it doesn't annoy the operator and he can focus his attention on ensuring that he can fix that process upset. And finally, the important one is have distinct tones for priority, right? Like there are various priority of alarms like low, high, emergency, or critical. So having these distinct tones help the operator in ensuring that which alarm he needs to like timely act on, and also will give him that level of focus based on that audibility of that alarm. So the next one is visual annunciation of alarm. So ensure that the critical information such as alarm summary process overview is within 30 degrees, right? And also on an angle plane. So yeah, that is the preferred position where the operator can look at information and digest information. As soon as it goes beyond the 30 degrees on the left or the right, then it starts to become difficult for the operator to actually digest that yeah, information. It is not clearer to him. So any key alarm or trend information, it is important that your control room is designed so that the viewing angle is within the 30 degrees. Okay, so that brings us to the conclusion, and I'll just make few important points that is again part of the guideline, which is like ensure all operators like receive training on all the displays, like whether it's a greenfields project or a brownfield projects. Like training is very important, and it helps in ensuring the operator uses the displays appropriately. Uh, ensure simulation-based training is provided for like task-specific learning. For example, like most of the process plants have got a simulator which kind of simulates like process upsets and will allow the operator to learn without having to be on the production world to learn. It is more stressful to learn in a production environment than in a simulated environment. It is always helps when the operator are involved in the development activities of the displays, and also ensure management of change, captures any major display changes, and it is like well communicated to the control room operators and the field technicians, so they are aware of it. So with all that, the key point is the implementation of an like the individual guideline, like we saw many guidelines, right? Like the implementation of those guidelines in itself, it will not guarantee improved effective operation, but together when all these guidelines are implemented, it will kind of like will definitely lead to a lot of improvements to the operator displays and assist in helping the operator in like controlling the abnormal situation. With that, I say thank you, and if any questions, I'm happy to take questions.
Thanks, Santosh. We will continue on. AK, if you're happy to continue with your part, and we will hold a Q&A session at the end of this webinar. We should be wrapping up in about 5 to 10 minutes. Thank you.
Thank you so much, Riley. And thank you so much, Santosh. Yes, I can see quite a lot of interest in questions for Santosh regarding the presentation. Santosh, you can probably have a look through the chat box and see what questions they have and maybe reply to some of them in the chat box. Meanwhile, I'll just do a quick, can you hear me, everyone? Sorry.
Yep, sure, okay.
Yep, sorry. Yeah, meanwhile, I'll just do a quick introduction to the topics in general that you mentioned today. Abnormal situation management, such an interesting topic. Now that in the larger context falls within the area of industrial automation. So one of the reasons we wanted to have the webinar is to give you guys some ideas about industrial automation and the different fields it has, so that if you're interested in learning more about it, we have lots of courses here that we thought you might be interested in. So as Santosh mentioned about abnormal situation management, that's one part. So to be honest, industrial automation is a big field that covers a lot of things. So whether it's packaging, quality control and inspection, whether it's food and beverage industry, whether you are installing smart meters at home, smart meters in an industrial setup, whether it's any sort of planning or decision making. In different areas, automation has slowly but surely taken a huge role. Whether you are using a computer to make to control certain operations, or like as you saw how safety measures are taken and how SCADA is a critical part in an industrial operation, or whether you are using smart sensors to collect data and get information about whether a particular equipment or a process is learning fine or not. So industrial automation is any process where you're using control systems as well as IT technology, whether it's the older IT technology or the more advanced IT technologies nowadays, to control different operations and different processes. So basically you're automating the process with the help of computers, robots, and different ever evolving IT technologies. So I think you guys are pretty aware of that. So given the short time, I won't take too long in explaining that. But of course, if you guys want to learn more, feel free to ask me questions later on. In terms of industrial automation, as you can see, we're in the fourth stage of industrial automation, or Industry 4.0. It started with Industry 1.0 almost more than 200 years ago now, where they used steam-powered engines for agricultural purposes. Then with the innovation of electricity, they started processes of mass production where they could use control and operation and build the same stuff in a patch, basically. Then came Industry 3.0 about 50 years back when the computers came and you could, instruct computers to control an operation and give instructions, a single operation. And now, about for the last 10, 12 years now with Industry 4.0, it's all about interconnected machines, where it's cyber physical systems. So all machines and industrial IoT. So all machines communicating with each other, they can collect information, send it to the cloud, more calculation, more higher level operation being, higher level information being calculated and operated. And later on, probably in a few years, maybe in another couple of decades, we'll be going to Industry 5.0, where actually robots were already here, but they will be operating in a more efficient manner side by side with humans. So industrial automation is here to stay, and it's a ever progressing area. The interesting thing with industrial automation, as I mentioned, it's a vast area. Whether it's an operation floor, whether it's it's a smart home, smart city, everything, the automation carries on. And the interesting part about industrial automation is it's such a vast field. It's actually relevant to people from different backgrounds. As a result, people from different backgrounds can come and learn about industrial automation. Manufacturing, power plant, industrial engineering, control engineering, mechanical engineering, power engineering, electrical engineering, process, oil and gas, someone was talking about. Everything is actually relevant to industrial automation. And that's why some of our courses at EIT actually is very helpful, because people from different backgrounds can come, and we try to set the courses in a way that even if you are, let's say, from a mechanical background and trying to learn a course on, let's say, an electrical part of the automation, you will have the basic fundamentals covered, because we know this is the necessary fundamentals you need to understand that subject, basically. While we have many courses, I'll just quickly go through some of the topics we have so that you have an idea about what we are covering here. But of course, you can see the website later on to learn more. But as you can see, we have the advanced diploma program, the Bachelor of Science, as well as Masters. We also have a doctorate program as well. And I think Riley will tell you a bit more later on. But just given the short time, I'll just give you some idea about the topics or the type of units we have. We have units on instrumentation. We have topics on process engineering, like controlling an like a industrial process with some use cases. We have communication related topic like TCP/IP, Modbus, industrial Ethernet. We have topics on distributed control system. We have topics on PLC. We have topics on SCADA, and all of them. We have topics on IoT now, which is a new topic. Similar to what Santosh was talking about, we have lots of topics on safety systems like HAZOP, safety instrumentation, and so on. And all these topics we have at an advanced diploma level. We have the same topics or more similar topics, but at an advanced stage with more advanced settings for a bachelor level. And of course, for the master's level as well, you will see we have more advanced topics such as like a pure complete unit on machine learning, SCADA, and so on. So you will actually be coming to a program where you are learning different aspects of industrial automation. And so based on that, you can go to different areas later on. And we have courses on online as well as on campus. And we try to keep the experience the same from our previous experience. So even if you are from online with the remote lab services we have, you will get the best possible experience to the best industry standard softwares, as well as remote control of some of the hardwares, in some cases using PLC as well. So we have quite a few courses. I think Riley, you can probably go through them, but yeah, if there are any other questions related to that, feel free to ask me. Otherwise, once Riley finishes, I think Santosh can answer a few questions as well. Thank you.
Thanks very much, AK. I can see there's quite a few questions coming through. I have seen a few people have been talking about the course fees, so I'll just put a link in the chat box there if anyone is interested in looking at our fees. That page will show all of our course fees for our courses. So you just need to put in your country of residence at the top, and then it will display all the relevant course fees for you. This little table that I've got here is is basically a schedule of upcoming courses in the field of industrial automation. We've got a lot more courses than these because we have we cover various other fields of engineering, but since this is a industrial automation related topic today, I've listed the courses there in that field. So you can see we've got professional certificates. So those are the 3-month short courses. They are non-accredited, but their benefit is mainly for those already working in industry, possibly wanting to upskill some professional development. Now we have an undergraduate certificate in industrial automation starting on the 14th of February. And we've got a range of other courses such as advanced diplomas, one in industrial automation. We've also got a robotics and mechatronics advanced diploma. And we have 4 graduate certificates in industrial automation field, and they are starting on the 27th of June. And our Master of Engineering Industrial Automation online, that is also starting on the 27th of June. Now, due to the limitations of the slides, I can't display as many courses as I would like to, so just encouraging you to go to our website, have a look, go to the schedule page, or the link is also there for you. I'll put it in the chat box if anyone's interested. So the schedule shows all of our upcoming courses, so you can browse that in your own time. Now, we've got a webinar next week if anyone's interested. It's not a technical topic webinar, but it is a webinar focused on engineering trends and what kind of courses we offer at EIT and how we are responding to those trends in industry. So that's actually being presented by our Dean of Engineering at EIT, Dr. Steve Mackay, and our Deputy Dean, Indu Mathi. So that's definitely an interesting webinar. If you want to go and register for that one, you can find that on our website under news and events, and then you can go to events or webinars and you can find that one to register for. So that's mainly if you're wanting to become if you're interested in becoming a student at EIT, that's definitely a good one to register for. Now, as mentioned, we do offer a free certificate of attendance for this session. So I'm just going to leave that slide on for a minute or so. So please access the form or survey which is required to receive a certificate of attendance. If you've got your smartphone there, you can scan that code with your phone's camera. Otherwise, you can click the link in the chat box. I'll just provide it shortly. If you click that link, you can fill out the short form or survey, and you'll receive your certificate of attendance within the next business day. I'll send those out to anyone who's interested in that. Now, that concludes the webinar for today. So I hope you've all enjoyed it. Thank you to our presenters, AK and Santosh, for their delivery. And yeah, we will hold a Q&A session though. So if anyone is interested, just stick around and post any questions that you may have in the chat box, and we will try to answer them for you while we're live. So I think we'll stay on for a few more minutes. I think Santosh, if you've got I think you've got a class after this, so it's okay if you need to go now. But AK and I will stay on for sure.
Sure, Ali. I'll just wait for another minute, and if there are anything, I can answer. Otherwise, yeah, always they can send me the questions in an email, and I can provide them the response.
Absolutely. Thanks, Santosh. I'll put my email address in the chat box as well. So if anyone does want to send an email with some questions, they can always do that. And if it's an academic question, I can forward that on. Now, if anyone's got any questions, please post them in the chat box. Otherwise, thank you for attending this webinar today. And all of our contact details are on the screen if you would like to contact us, including our schedule page as well, which shows all of our upcoming courses. Jean, yes, so I'll be sending an email out tomorrow, so within the next business day with the PDF slides and a link to the video recording of this webinar today. Now, Santosh, there's a few questions from Clyde. Do you mind having a look at those, or do you have time?
Sorry, Riley, I think better to do them through an email. So I'm just running late for the class. So,
No
yep,
worries.
thank you all. Have a good evening.
No worries. Thanks, Santosh. Clyde, if you would just like to send me an email to the email address that I provided, please just send me an email, and I can forward all your questions onto Santosh. Unfortunately, he's got a class right after this webinar, so that's why he needed to leave. However, we have AK online as well, so we can answer any other questions that come through, hopefully. As mentioned, you will receive an email with the PDF slides and a link to the video recording within the next business day.
Yeah, hi Riley. I'll just answer to Philip there. He asked a question. Are there, other than the fees difference, are there any changes in topic or any other extra modules for exclusively on campus? So that's no. So it's the same modules as you would have learned online as well as on campus. So it's the same unit outlines and same courses basically.
Yeah, and just to add on to that, Philip, so we have two campuses in Australia. We have one in Perth, Western Australia, and one in Melbourne, Victoria. So with our on-campus program, you'll be looking at full-time study at one of our two campuses if you're interested in on-campus studies. However, the online mode is fully online, so our online mode is most popular. We have students from all around the world studying with us online in a range of different qualifications. But there is a significant fee difference between studying online and on campus. There are a lot of questions coming through. Unfortunately, we won't be able to get to them all. However,
I saw a question from Yusuf asking about are there any courses on power system related? So I think there are quite a few courses there. So yeah, we just have to relate to the website, I guess.
Yeah. I think we also have a graduate certificate in power system analysis, I believe. Let me just find that for you. If you go to our website anyway, look at our schedule page. I really recommend looking at that, which shows you all of our upcoming courses. And AK has just posted the link in the chat box there. Now the certificate of attendance link, is that working for you all? It appears to be working for me. So once you fill out your details on the form there, you will get a confirmation, and then I'll send out a certificate of attendance to you within the next business day. The undergraduate certificate in industrial automation, that one is accredited with the Australian government. However, it's not an internationally recognised qualification. It's not under any of the accords, but it is accredited within Australia. Yep, so we do have a master's in electrical engineering. You can check that out on our website. We do offer it online and on campus. We have a range of scholarships that you can look at on our website under how to apply. Zahid, I would encourage you going to the website and looking at fees, the fees page, which is under how to apply. If you go to our fees page, you'll see all the fees for all applicable courses. Joseph, I'm just going to copy the link for the certificate of attendance. Please access that one in the chat box. If you click that link, you'll be able to go to the certificate of attendance form. Jimmy, I've just posted the link to the certificate of attendance. It should be working. I just tested it. If you click that link, it will take you to a short form or survey, and then your details will be recorded, and I'll send you your certificate. The Masters in Electrical and Instrumentation Engineering and Oil and Gas, as mentioned previously, the intakes are to be announced. I don't have any information about the scheduling of that course at this stage, but definitely please send me an email at webinars@eit.edu.au, and I can definitely follow that one up for you. Prince, I will send an email within the next 24 hours, including the PDF slides of this session. Mandeep, I'm not entirely sure on that. I would recommend you contact us and speak to one of our course advisors to see what suitable courses there may be for you. Okay, great. Well, I think that's about all we have time for today. However, all of our contact details are on the screen, so please send me an email at webinars@eit.edu.au if you have any questions, or if you would like to send a question to me or to one of the two other lecturers that presented today. Otherwise, our phone numbers are there. Visit our website. Yeah, please reach out. Thank you very much for coming today, and I hope you enjoy the rest of your day wherever you are. And thanks, AK, as well for staying on and presenting the webinar.
Thank you so much, Riley. Thank you everyone for your attendance. Feel free to email if you guys have any questions. Happy to answer. All the best.
Thanks, AK. Thank you very much, everyone. Have a good day.